A resistor's main job is to limit the flow of electrical current and to help divide voltage in a circuit. Let's look at the key properties of resistors. First, resistance. It's measured in ohms with the symbol omega. Resistance determines exactly how much a resistor opposes, or resists, the flow of electric current. The higher the resistance value, the less current flows for a given voltage. Second, power rating. This is measured in watts with the symbol W. It tells you the maximum power the resistor can safely handle before it overheats and possibly fails. For example, a common 1/4 watt resistor can safely dissipate up to 0.25 watts of power. Anything more, and it may burn up. Now, how do resistors actually work? They follow Ohm's law, one of the most fundamental rules in electronics. The formula is simple. R equals V divided by I, or resistance equals voltage divided by current. V stands for voltage across the resistor, measured in volts. I stands for current flowing through the resistor, measured in amps. R is the resistance, in ohms. This relationship lets us calculate any one value if we know the other two. Resistors come in different types. The most common are fixed resistors. These have a single, unchanging resistance value. For example, a 1 kilo ohm resistor always provides 1000 ohms of resistance, no matter what. Then there are variable resistors, also called potentiometers. You can adjust their resistance manually, usually by turning a knob or sliding a lever. You'll find them in everyday items, like volume controls on radios or light dimmers in your home. Many through-hole resistors use colored bands to show their value, because printing tiny numbers is difficult. This is called the resistor color code. Each colored band represents a digit, a multiplier, or the tolerance. Let's take a classic example. Brown, black, red, gold. The first band, brown, stands for 1. The second band, black, stands for 0. So together, the first two bands give us the number 10. The third band, red, means multiply by 10 to the power of 2, or 100. So 10 times 100 equals 1000 ohms, or 1 kilo ohm. Finally, the gold band indicates a tolerance of plus or minus 5%. That means the actual resistance could be anywhere from 950 ohms up to 1050 ohms. Now, let's see a practical real-world example using a resistor to safely light an LED. You'll need 3 basic components. 1 LED, 1 resistor, we'll use 330 ohms, and a 9-volt battery. Why do we absolutely need that resistor? An LED is a diode. It only allows current in one direction, and it has a very low internal resistance once it turns on, without a current limiting resistor. The full current from the battery would flow through the LED, quickly exceeding its maximum current rating and destroying it in seconds. The resistor drops excess voltage and limits current to a safe level. Let's do the calculation using Ohm's law. The battery supplies 9 volts. A typical red LED has a forward voltage drop of about 2 volts, so the voltage across the resistor is 9 volts minus 2 volts, which equals 7 volts. We want to limit current to around 20 milliamps. That's 0.02 amps, which is safe for most standard LEDs. So resistance equals voltage divided by current, 7 volts divided by 0.02 amps equals 350 ohms. The closest standard value is 330 ohms, which is perfect. It gives a slightly higher current, around 21 milliamps, but still well within safe limits. Using the resistor protects the LED, extends its life, and prevents overheating or sudden failure. That's it for this overview of resistors. They may seem basic, but mastering them is the foundation for almost every electronic project, from simple circuits to complex devices. Thanks for listening.